Hello and welcome to today's video on ionisation energies. This is quite a small topic in AS chemistry and it's a really easy one to get your head around, so we'll just get cracking. The first definition that you need to learn is that of ionisation, and that is that ionisation is the removal of one or more electrons. Or you could say, in other words, when electrons are removed from an atom or molecule, it has been ionised. Then we need to move on to this little definition here. This is the one given by the AQA revision guide, so it's probably the one that they want you to use in the exam because they've given it in their own revision guide. But your teacher might use another definition, and if they really want you to use that definition, then go ahead and use it. But this is the one given in the actual revision guide, and this needs to be ingrained in your memory. So we'll go over it a few times just to get the concept going. So the first ionisation energy is the energy needed to remove one electron from each atom in 1 mole of gaseous atoms to form 1 mole of gaseous 1+ ions. So we'll break it down. The first ionisation energy, that is what you would be asked in the exam. So it would say, define the first ionisation energy. So that is the words that you need to learn. Is the energy needed to remove one electron from each atom in 1 mole of gaseous atoms to form 1 mole of gaseous 1+ ions. You could write that on a flashcard, write it on the ceiling, pause the video, whatever you want to do. Just kind of try and learn that definition right there. So we're going to move on to actually kind of trying to show what a first ionisation energy equation would look like, and we'll do oxygen. So oxygen, you would write the symbol for oxygen, which is O obviously, and then you would write gas as its state symbol, because it specifies here that it has to be gaseous in both scenarios. And then you would just draw an arrow. Then you would write oxygen again, but as an ion. So O+, and it says here gaseous, so we need to put G for the state symbol. And then on the end, all you have to do is write an electron, because it's had 1 electron removed. So that is what the first ionisation energy equation for oxygen is. You would be given, or you might be asked to figure out, or whatever, the actual ionisation energy. The ionisation energy for oxygen is positive 1, 3, 1, 4. And the units for that are kilojoules per mole to the -1. So that's the how much ionisation energy, how much energy is required to remove the electron from the oxygen atom. These are the things that you need to kind of learn as the gospel for ionisation energy. You must use the gas state symbol, so you have to use that, otherwise you won't get the mark. Always refer to 1 mole of atoms. Don't just refer to 1 atom. It says in the definition here that 1 mole of gaseous atoms, so always refer to it as 1 mole. That's good. And then this is the little fact that you need to get your head around. The lower the ionisation energy, the easier it is to form an ion. So that just says what it is on the tin. Its ionisation energy, if it's lower, that means it's easier to remove. That's kind of just logical. Just remember that fact there, because you might be asked a question about it. And now we're going to look down here at these little 3 facts here. These are the 3 things that, or the 3 main things that affect the size of the ionisation energies. So the first one is atomic radius, and this is that the further out electron shell electrons means there is less attraction, so the ionization energy will be lower. So I'll just kind of do this here if you can understand. So this would be the first electron to pull off, and here we have the positive nucleus. The electron is negative, so they are obviously attracted to one another, but because it's further away, the atomic radius is bigger. That means that the ionization energy will be lower because it'll be easier to pull this electron off. Okay, so the next concept that we need to know is the nuclear charge. So if there are more positive protons, if there is a bigger nuclear charge, then there will be more attraction between the electron on the outer shell. So the ionization energy will be higher. So it was a really strong positive charge, there was lots of protons in the nucleus, then that would mean that the electron would be harder to pull off because the electron is more strongly attracted to the nucleus. So yeah, just that's pretty easy to understand, I think, but if you have any questions, just ask me. And the third concept is that of electron shielding. So the more shielding means the less attraction, so the ionization energy will be lower again. This is mostly like kind of the same concept as atomic radius, but the inner electron shields the outer electron from the attractive force of the nucleus, because more inner shields means more shielding. So if there's more shields, then there is more of a shielding effect, and that means that this electron will have a lower ionization energy because it will be easier to pull away from the atom. And that's the first video on ionization energies. I hope you understand. If you've got any questions, just ask me, and I'll see you again soon.